All right, here we have the page 8 notes from the chapter 8 notes, and I think this will actually finish out our notes for this chapter. And it really is a little tiny bit of it is a little bit of a review from previous courses. So at the very top of the page, factoring review, what we're going to do here, first and foremost always, is look for a GCF. GCF is a greatest common factor, so it is anything, either numbers or variables, that can be divided evenly from every single term that you are trying to factor. If there's a GCF, you definitely want to take it out. It will make your life easier. And then from there, this might be a little bit different. The whole idea of counting the terms. This is one of the things that I like to do. I think it makes it a little bit easier for me to decide what my next step should be. If you have 3 terms, I'm going to jump over the first one. If you have 3 terms, this is trinomial factoring. This is stuff that you did back in Integrated 2. So this is where you would use your diamonds and your boxes, typically. That is assuming that it's factorable, but kind of back up a little bit. Even if you can't use diamonds and boxes for something, that doesn't necessarily mean it's not factorable. If you could have taken a GCF out in the first place, then yes, you've already done some factoring. So we only say something's not factorable if there is no GCF, there is no way that we can use any of the patterns that we're going to discuss today. And there's nothing you can do. Okay, the 2 terms, this is going to be the new stuff. So we're going to do difference of squares, which is going to be our first one, cubes, and difference in sum of cubes. So one of the things that we're going to focus on primarily, to be honest with you, is just kind of some patterns. But I do want to utilize what we have done previously with the whole idea of division to help you out. And then you can decide, do I want to do the division or do I want to go straight to the punch using the pattern? It's up to you. So if we take a look at example number 1, first thing I'm going to go through my checklist is there a GCF? So I'm going to take a look at that. I like to look at them in pieces. So I'm going to take a look at the numbers first. I have an 8 and a 4. Is there anything that goes into both of those? Yeah, there's a couple of things that actually go into them. I want to choose the biggest one. That's the greatest common factor. And I'm going to go ahead and just start kind of piecing it together. So the biggest number that goes into 8 and 4 evenly is 4. Then I'm going to keep on going down the problem and I'm going to look at the variables. So I'm going to take a look at the x's here and the x's here. Remember, you want to take out the most that everybody can give up. So you can't take more than what somebody has, I think is the best way to put it. So if we take a look at the very first term, an x cubed means there's technically 3 x's in there, all being multiplied together. So that one could give up 3 x's. The second one, though, is an x squared, and it's 2 x's, so it can only give up 2 x's. So in this case, the most you could take from both of them is an x squared. So again, you can't take more than what somebody has. So I'm going to take an x squared out. And then the next thing I'm going to do is I'm going to take a look at the next variable. In this case, I have a y here and a y here. So the first term has 1 y, so it can give up 1 y. The second term has 1 y, so it can give up 1 y. Okay, so they can each give up 1 y. So we're going to put that here. That's going to be our GCF. So I've already gone through, if there were z's and k's and t's or whatever variables else that I have, I would continue in the same fashion. So with this, I now take my GCF and I'm going to put it out in front of a set of parentheses. Now I'm going to do my division. So I'm going to go through and I'm going to take a look at each one of the terms here. So I'm going to go again in chunks, but I'm going to take a look at the entire thing. So I've got an 8 here. Well, with a 4 on the outside, that's going to be a 2. Then I keep on going. I've got an x cubed, so that's 3 x's, so I have 1 x left over. And then I keep going through the y. I took out the 1 y, so I have no y left over. So that's it for the first part. Now, I'm going to do the exact same thing for the second one. So I have a -4, okay, I'm dividing, so this is going to be a -1. Right, I've got an x squared. Well, I took out 2 x's, so no leftovers. And then I have a y. Well, I took out a y, so no leftovers. I think that that is what I get when I factor. But just like anything else, kind of like when you're solving a problem, you have to keep asking yourself, am I done? Have I done everything that I can? So whenever you go through and you factor, you want to take a look at the resulting polynomials, so the factors, the chunks that you got out of it. With the GCF out in front, because there is no addition or subtraction involved with this, we know that there is no further factoring to do. So we kind of ignore that part. But we do look inside the parentheses. So anytime you create a new set of parentheses, check the parentheses. Make sure that you're finished. So if I take a look at the 2x minus 1, there is 2 terms. Okay, that's fine. But there is no GCF between them. So nothing goes into both 2x and 1 evenly, except for 1. Everybody has a factor of 1. So, but if the GCF is 1, we don't take it out because dividing by 1 doesn't do us any good. Then I would take a look and see if there's any exponents on any of the variables. If there are exponents on the variables, then like my heightened awareness kind of picks up and I go, oh, okay, wait a minute, is there anything else I can do? In this case, no, there isn't. I don't have any GCF left over inside. I don't have an exponent on my x's inside the parentheses either. So that's going to be it for the first one. Now let's move on to the second one. Okay, so second one, I'm going to go through the exact same process. One, is there a GCF? Well, I don't think so. If I take a look just at the numbers, you have a 4, and a 15. Yes, of course, there's negative signs in there as well, but with the 4, and the 15, the biggest number that goes into all of those is just 1, so that doesn't do me any good. And I take a look at the variables. I have an x squared and x and no variable. So remember, you can't take more than what somebody has, so there's no x's that I can take out either. So in this case, now I take a look at how many terms. Well, I have 3 terms. Okay, we're now in the type of problems that you guys did last year. So I would try to use my boxes and my diamonds on this. So I'd go ahead and set up the box. And then however you chose to set it up last year. So if you put your x squared kind of in the bottom and your negative 15 in the top corner. Remember, when we multiply those two things and then find the term that actually represents the middle, negative 4x, that's the guy that goes in the bottom down there. So we're going to put the negative 4x in the bottom. And then as a reminder, this is just a tool, folks. That's it. If you don't use the generic rectangles and the diamonds, that's totally fine. We know that we want to multiply to get the number on the top, and we want to add to get the number on the bottom. So I believe this is going to be a negative 10x and a positive 6x. Those two go into the 2 empty boxes. It doesn't matter which one goes where. And then from here, we divide. So I'm going to take a look at that entire first column. So I'm going to look there and ask myself, what goes into both of those evenly? Well, with the 4 and the 10, I believe it's a 2, and the x squared and the x is going to be a x. So this is going to give me a 2x. Then I'm just going to kind of start zigzagging, well, crisscrossing my way through this. So then I look here. What goes into both of those? I believe that's going to be a 3. And then you can hold off on the signs if you want until the end. Okay, so now let's start going across. So I take a look here for my 4x squared plus 6x. Believe that that's going to be a 2x. And then as you're going, remember that you want to multiply the outside of the boxes to make sure that you're getting the correct thing. And then the last one right on top is going to be negative 10x and negative 15x. So I believe that's going to be a minus 5. Do a quick multiplication, make sure everything works out, and then let's rewrite our answer. So we're going to have our 2x plus 3 from across the bottom, and then 2x minus 5 from up the side. Now, do the same thing that we did previously. You created new factors. You need to check each of those factors and see if you can keep factoring. So take a look inside at the first one. There is no GCF other than 1, and there's no exponent on the x, so I don't think the first one can be factored. Take a look at the second one. Same idea. So no GCF other than 1, no exponent on the x. I think that we are done. So that is the factorization for this problem. All right. Number 3. Number 3, first thing, GCF. So I'm just going to take a look at the coefficients themselves again and see if there's anything that I could take out of those. So I've got a 4, a 10, and a 24. Those are all even numbers, so I know 2 goes into them evenly. If you take a look, and if we divide them all by 2, I'm going to get a 2, a 5, and a 12. Okay, so the 2 and the 12 made me think that maybe I could take it something bigger, but the 5 told me no way. So I'm going to go ahead and take a 2 out of these guys. Then take a look at the variables. We've got an x squared, an x, no variable, so can't take an x out. So open up a set of parentheses, do our division. So 2 goes into 4x squared, 2x squared times. We'll take a look at the 2 goes into negative 10x. That's going to be a negative 5x. And then the last one, 2 goes into negative 24. It's going to be negative 12. Okay, close the parentheses. Now, right aside, every time you create a new set of parentheses, check and see if you're actually done. So if we look here, I see no GCF other than 1, but I do see an exponent on my x. So I look to see how many terms I have. Well, I've got 3. So thinking generic rectangles. So like what you guys did last year. So if it were me, I would pause at this moment, see if you can get the 2x squared minus 5x minus 12 factored just out of the boxes and see what we get. And then we'll work on writing our answer. Okay, so I went ahead and factored this. So now I have my new factors from across the bottom and down the side. When you go through and you replace this, so if I go back up to where my factorization is, these 2 new sets of parentheses are going to replace the parentheses that we'd already created by factoring out the GCF. But don't forget, you need to make sure that you take your GCF with you. So that 2 needs to go in front as well. So you kind of just take it along for the ride. Okay, then from here, I'm going to take a look at my factors inside, and because I created a new set of parentheses. If I look in here, the GCF is just 1, and there's no exponent on your x, so that one's factored. If I take a look at the next set of parentheses, x minus 4, GCF is 1, and there's no exponent on the x. I believe that we are now done. So that is our answer to this problem. Okay, and then 4 is just like what we did with 2 and 3. So go ahead and take this moment, pause, see if you can get this entire thing factored. Remember to follow the steps. GCF first, then inspect the problem that you created, so the new parentheses, and see if there's anything else that you can do from there. Okay, so here's my factorization. I did make sure when I took out my GCF to put it in my final answer as well. And then you can see my work off to the side with the diamonds and the boxes. Took the 2x minus 1 and replaced it as a factor. Additionally, the 3x plus 7. If I take a look inside the new parentheses, there are no GCF other than 1. Additionally, there are no exponents on my x's. I believe that that is my answer. Okay, let's take a look at the next page. So just kind of a continuation of where we left off. However, we're now dealing with some new patterns here. And I'm going to show you a couple of ways to do this, and then you can decide which way makes the most sense to you and which way you would like to do this. So first thing I'm always going to do still is look for a GCF. So if I take a look at my question number 5, I have a 4 and a 25. The GCF is 1, so there's no number coming out of this. If I take a look at the variables, well, not everybody has a variable to give up. So what you could do, if you would like to, this is 2 terms, so there's probably going to be a pattern to it. However, you can treat it as 3 terms if by inserting the middle term, it looks like a trinomial, like the stuff that you guys have done in years past. So we could rewrite this as 4x squared plus 0x minus 25. If you take a look at it, now it looks like something that you did previously. So we could proceed the way that we have done in the past. So if you wanted to, and I'll show you a nice neat little pattern to this in just a second. So we'll take that 4x squared and that negative 25. So that gives me a negative 100x squared and a 0x. Okay, well, it's going to be 10 and negative 10. There's nothing else that'll do this. So 10 and negative 10. Go ahead and put those into the empty boxes. And then factor. So it gives me a 2x minus 5 and a 2x plus 5. So my factorization is going to be 2x minus 5 across the bottom and 2x plus 5 up the side. Now, we could have actually gone straight to the punch on this because there's a nice neat little pattern that happens. So if we take a look back at the original question, before I even put the 0x in, you don't really even need it. If you take a look at the very first term of 4x squared, and I want you to imagine that you can square root that term, the whole term. You have to be able to square root the number, and you have to be able to square root the variable as well. And by that I mean neatly. You don't want weird decimals or like a square root of 7 to appear. You also want the exponent to be nice, so no fractions, decimals, at this point, if you can avoid it, okay? So if I wanted to square root that term, the square root of it is going to be 2x. Notice in my factorization that both of the first entries are that value 2x. And if I go back and I take a look at the 25, so just the 25. So just the 25, if I square root that, that's going to give me a 5. Notice that the second entries are 5s. However, one of the things that's important to note here is that you must have a subtraction sign on the 25, because when we put these into factored form, we need to make sure that that 0x squared shows up for us. If it's going to be both positives or both negatives, then we're not going to get that 0x squared in the middle. So probably like the key things here is making sure that in the original question it is a minus between them. Otherwise, we cannot factor this. What this is called is a difference, because it's subtraction, of squares, two things that you could square root. So we could have actually just gone straight to the punch on the factorization there. I also took a moment while I was talking and looked to see, do I have any GCFs inside them? No. Do I have any exponents on my x's? No. So I know I'm finished with this one. Okay, let's take a look at the next one. I see, do I have a GCF? Yes, I do, actually. I can take out a 3 on this. So I'm going to go ahead and take a 3 out. If I divide by 3, It's going to give me 25x squared minus 1. Okay, now I'm going to take a look at the stuff inside. So that whole thing right there in pieces. So if I take a look, so I'm going to use the pattern here. You're welcome to use the boxes if you would like. I'm going to take a look at this very first term with the 25x squared. And I'm going to ask myself, can I square root that nicely? And yeah, I think I can. The square root's going to be 5x. Okay, but you got to be able to do both of them. So I'm going to take a look at the next one. I have a 1. Can I square root that? Yes. Yes, I can. The square root, notice I'm ignoring the negative sign. The square root of 1 is 1. Last but not least, you can only do this if it is a minus sign. It is. This is good. So what I'm going to do is I am going to copy down what I already wrote once, the 5x and the 1. I'm just going to leave a little bit of space. My 5x and my 1. Then I'm going to bring down my GCF. And wherever I put the 5x and the 1, I'm going to put parentheses around those guys. And then the only way to get that minus in the middle is if one of these is positive and the other one is negative. Do a quick check. See if you can factor the inside. And I don't think that you can. That is our answer for this one. So was the difference of squares and a GCF involved. Okay. Taking a look at question number 7, first thing I'm going to do is look for a GCF. Well, I don't see one. I mean, I do. It's a GCF of 1, but dividing by 1 doesn't do me any good. Then I would take a look at the variables. I've got an x cubed and then no variable, so definitely not a GCF with a variable. Then I take a look and I ask myself, well, how many terms do I have? Well, I've got 2. All right, so I'm thinking patterns here. Well, the only pattern at this point we've learned so far is a difference of squares. If you take a look at just the first variable, there's no way this is a square. Because if I take the x cubed and I try to like split it evenly, then that's going to be a 3/2 and a 3/2, or a 1.5 and a 1.5. And that doesn't do me any good. So I want my variables to look nice. All right, so it's not squares. So we have a new pattern that we want to talk about, and it's actually cubes. So I'm going to follow the same process here with a little bit of extra work. So if I take a look at the very first one, I'm trying to determine if I could cube root that term. So could I take the cube root of 8x cubed and get something nice? I want something nice. Yeah, I can. That's going to be a 2, and then the cube root of x cubed is x. Now, as a reminder, so a little off to the side work, if you want to do a cube root of x cubed, think about those fraction exponents. So remember that it is power on top and root on the bottom. Root on the bottom. So if we simplify that, we're going to get, well, 3 divided by 3 is just 1, so we get x. Okay, now back to the problem. Now we want to take a look at the next piece and ask myself kind of the same thing. Can I cube root that term? Okay, well, let's see. Can I cube root that term? And actually, yes, I can. It's a 3. All right. I don't care if it's plus or minus, to be honest with you. I would like to be able to cube root each term, regardless of whether they're positive or negative. Now, what's really nice is you can cube root positive terms and you can cube root negative terms. Okay, so said I would show you a couple of different ways to do this. So without using the pattern itself, which we're going to establish here in just a second, You can actually use this as a division problem, so what we just did with generic rectangles. So we can go ahead and set this up. So the first thing we're going to put inside is the 8x cubed. Then we're going to take the cube root that we found, and we're going to put it on the left-hand side. So I'm going to go ahead and put that 2x out there. Now we know that these two terms together here would be an x squared term. Okay, then extend this guy just a little bit. I know that these two terms would be my x term, and then down here in my bottom corner would be my constant. All right, so what I'm going to do is I'm going to close this box off here, and I'm going to put my constant in. So I actually get to put two things in this time. So I'm going to put the 27 down here. Then I'm going to take the cube root that I had found, and I'm going to put it out there. And that's going to be a 3. And it is, well, the cube root of 27 is positive 3. Now we're going to fill in the rest of the boxes. So using the division that I know that this is going to be a 4x squared. Fill in the bottom box. Okay, so now we're going to make it work, I think is the best way to put it. We know that those two added together need to give me the x squared term. However, there is no x squared term, which means I need this to be a negative 12x squared so that my 12x squared cancels. And then I'm going to divide that. So it's negative 6x, and that's negative 18x. Okay, same idea. We're going to go through. We know that those two together need to give us the x term. Well, there is no x term, so this needs to be an 18x. All right, if we did this correctly, this last one will work for both the 18x and the 27, which it does. So what we just did was we factored by using cubes. So down the side we have our 2x plus 3. And then across the top we have our 4x squared minus 6x plus 9. Now, I always inspect what I have. But one of the things that's really nice about this is if there was no GCF to begin with, at this point you may have more complicated factoring problems in your future, and in future I mean future math classes. Assuming that we dealt with any GCFs in the first place, hopefully, this set of parentheses should be good. If it isn't, continue factoring. This trinomial you get out of it, assuming that you factor the first one, is not going to be factorable. So I know that I'm actually done there. Okay, the next problem is the exact same process, except I'm going to see if I can show you the pattern here. And there is something that was kind of nice about this, and we'll go back to the previous one so you can see it. So if I take a look, I'm going to take a look at the 64x cubed. I'm going to ask myself, I checked for GCF. Again, most of the time when I say I checked for GCF, it's a quick check. It's like I look at it and go, nope, or yes, okay, take it out. I've already gone through the how many terms is this? Well, it's 2 terms. I've already looked to see if I could square root something, and I can't. So now I'm trying to cube root something. All right, so if I cube root this, I believe that that is 4x. If I cube root the next piece, again, we're going to cube root the sign as well. If I cube root that, that's going to be a -1. Okay, here's the pattern. If we take these guys, and I'm just going to kind of ignore the original question for just a minute. Like I'll come back to it later. So the only thing I'm going to be looking at now is the bright yellow. It's the only thing I'm looking at. So from here, I'm going to use the bright yellow to build my next set of parentheses. Okay. take the very first term and you are going to square it. So right here is the blue term squared. Leave a little bit of space. The next thing I'm going to do is I'm going to take both of the terms, the 4x and the 1, ignore the sign for the moment, and I am going to multiply them. So let's do a little bit of color coding here. So I'm going to take those two guys and I'm going to multiply them together. So I will do blue times orange right next to each other. Then leave a little bit of space and I'm going to take the second term, the orange, and I'm going to square it. So now I'm just going to put everybody in where they go. So I've got my 4x minus 1 that I'm carrying down with me. Take the blue term and square it, so that's going to be a 16x squared. Take the two terms and multiply them together. I'll deal with the sign in just a minute. And then take the last term and square it. Now, one of the things that's nice with the signs themselves is that we use this idea, and this is in your notes, of SOAP. The S stands for same. The O is opposite. And the AP goes together as always positive. So if I take a look back at the original question here, and I'm just going to look at the signs. There's only one sign in there. So in this case, with that one sign, I want the first sign to be the same. I want the second sign to be opposite, and I want the last sign to be always positive. Now if I take a look at my factorization, I take a look at the first set of parentheses. There's nothing I could do with the 4x minus 1. I dealt with any GCF that I could in the first place, and that next trinomial is not going to be factorable. And that's my answer for this question. So now you've got a couple of different options or choices, and it's ultimately up to you if you want to use the method that I showed you on question 7 or the pattern on question 8. So why don't you go ahead and pause. Remember, you should always look for a GCF first. A little hint on this guy. Pause and see if you can factor question number 9, and then turn it back on and let's see if we match. Okay, so we're on question number 9, and I chose to use the pattern, primarily because this was how I was taught a really long time ago. Additionally, you guys know me, I'm a big fan of patterns. So if I get to use a pattern to solve or simplify a question, I'm all for it. So double check your answer against mine. I did take out a GCF of 3, and I made sure to carry it with me. Check my signs, and you will see that it was the same as the original sign, the opposite of the original sign, and then always positive. If you're not sure on these types of problems if you got something correct or not, the beautiful part about factoring is that you can always multiply out what you got and see if you match the original question. So see if you're right. Then I take a look at my parentheses. I am confident there's nothing else I can do with them. So that is the correct answer for this one. Okay, now this next one I think is a tiny bit tricky. Not a huge amount, just a little bit. If you take a look, I do have a GCF. I've got a GCF of 3. So if I take that out, it's going to give me a 25x cubed and then a minus 1. Okay, on the inside of the parentheses, I do see that I have 2 terms. All right, so I think it's a pattern. Second thing is I look to see if I could either cube root or square root. So since this is a minus sign, it could actually be either one of them. But in fact, it's neither of them, because if I take a look at this very first term, I want to square root the 25, but I would like to cube root the x cubed. Well, I don't want to do both at the same time. It's one or the other, not half of one and half of the other. So don't think that this can actually be factored any further. I actually think that's the best we can do. Okay, that finishes the notes. I did come up with a couple of extra problems for you guys that'll give you some practice. And then, so 11 and 12 are much like what we have just been doing. 13 and 14 are a tiny bit trickier. Not a huge amount, just a little bit. So what I would do is I would go ahead and pause, work on and complete question number 11. And then once you have it done, go ahead and start the video up again and see if you match. Remember, you choose how you want to do these problems. Okay, so again, I used the pattern. I noticed that I had no GCF other than 1, so that didn't do me any good. And then I looked to see how many terms I had. Well, I have 2. There is a subtraction sign, so it could have been squares. It's very possible. But in fact, it was cubes, and I know this because of the second term. And it's the exponent that kind of gave it away. So then I did the cubes here. So I cube rooted to get the 1. And then I cube rooted to get the negative a, and then I used my pattern. So I take the first one and I square it. That's how I got the 1. Then I took both of those guys, ignoring the sign, and I multiplied them together to get the 1 in the middle. And then I took the last one, ignored the sign, and I squared it to get the last piece. And then I used that SOAP that we talked about. So same, opposite, and always positive. And double check, make sure that it can't be factored any further. Okay, same idea. Go ahead and pause. My recommendation, always look for a GCF first. Always, 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 always. And then do number 12 and then see if we match. Okay, so I did notice that there was a GCF. I also noticed that I could square root them, but if you square root each of the terms now and then you factor, you're still going to have to take the GCF at the end. The majority of people struggle with taking a GCF out late. They're fine taking it out early. It's just hard to take it out later. So take them out in the beginning if you can. It'll make your life a little bit easier. Then I took out my GCF of 4. But you'll also notice that now inside the parentheses, I still have a difference of squares. So from here, I'm going to go ahead and use my difference of squares pattern. So take the first guy, square root him, that goes in twice. Take the second guy, square root him, that goes in twice. And the only way this had a chance of working was because there was a minus sign between the x squared and the 25. It must be a difference of squares. With a plus sign, it's not going to work because you're not going to be able to get that 0x in the middle. So you'll end up with too much stuff. And then double check your parentheses. Make sure there's nothing else you can do. Okay. Moving down to 13. With 13 and 14, I decided to give you guys some problems with some bigger exponents. So the idea is the same though, but you're just going to have to keep kind of chipping away at some stuff or really use your knowledge of exponents on these. So if I take a look at question number 13, there is no GCF other than 1, so that doesn't do me any good. I do have 2 terms, all right, so I think it's a pattern. Then I look to see what I can do to each of those 2 terms. So if I take a look at the very first one, I have an even exponent of 4. That means it's definitely going to be squares, but it could be cubes also. So if you take a look, think about taking the exponent of 4 and dividing it. 4 can evenly be divided by 2, so it's definitely a squares. The 4 cannot evenly be divided by 3, so it's definitely not a cubes. So definitely a squares here. All right, so I'm going to go ahead and I'm going to take this first term and I'm going to square root it. So remember what we said about fraction exponents. So this is going to be x squared is going to be the first entry in each of them. And that's because it came directly from the x to the 4th. Then we're going to take a look at the next part. Okay, we've got a, it's a minus sign, that's good. That's a 1. All right, the square root of that is a 1. And then close the second set of parentheses. The only way to get the minus is with a plus and a minus. Now, if you take a look, I'm not done this time. This one, you can actually factor further, but it's only this first one. It is still two terms. You can still square root, and there's still a minus sign. So, just looking at the first set of parentheses, I'm going to go through and do the same process. So, square root the first term, that's an x. So that's still coming from the yellow part. Then take the second term, square root that, that's a 1. One's a plus and one's a minus. But then we still haven't taken care of that guy, the x squared plus 1. Well, you can square root, but it's a plus sign. So there is no way that that's going to be able to be factored. But just like a GCF, you just kind of carry it with you throughout the problem. It's not like you throw it away. Now I think we're done. So this one was a difference of squares, but then there was another difference of squares inside it. Okay, question number 14. On question number 14, if we take a look at these two terms, they're both even, so I know there's a GCF. So let's go ahead and take out the GCF, and I think it's going to be 2. So if I take out a 2, it's going to give me a 125 and then a 27x to the 6th. All right. Now I'm just going to look at the stuff inside the parentheses. It's a plus sign, or it's a sum of two things. There's no way this is squares. Can't be. So I have to ask myself if I can cube root them. And I think I can. I think I can cube root 125 and get 5. And I think I can cube root the 27 with a 3. Remember what we said about exponents. If I cube root this, then I'm technically dividing the 6 by 3. So that gives me a squared. This is possible. So let's bring the 2 down, put parentheses around this guy. The cube root of positive 27 was positive. All right, now from here, you should be able to build out the rest of the pattern, whether you want to use the generic rectangle like area model or you want to use the pattern itself and go straight to the punch. Now would be a good time to pause. See if you can build the second set of parentheses. So what is the thing that goes in the next box? Okay, so I went ahead and used the pattern here. All right, so my first term was 5. So if I square that, I get 25. My second term is going to be the multiplication of those two terms, the 5 and the 3x squared. So that's where my 15x squared came in. I'll deal with the sign in just a second. And then my last term is going to come from 3x squared squared. So make sure that you square the 3 and you square the x squared. Then from here I go through and do SOAP. So go back to the original problem. Well, the one that you factored that was cubes. So it's going to be same, opposite, always positive. Okay, so I feel good about my signs. If I take a look inside the parentheses, only one I'm really going to concern myself with at this point is the first set of parentheses with the 5 plus 3x squared. There's no GCF other than 1, so it doesn't bother me at all. Don't have to do anything there. I do have an exponent of 2, but I only have 2 terms, and it's definitely not a difference of squares. Okay, I think that's the answer.